So today I want to take a look at something called a sandpile model. Here is the Wikipedia page for it. For some reason it's called a Abelian sandpile model. But it is quite simple. We have a grid, and on each point of the grid there is kind of like a number of grains of sand, usually between 0 and 3, 0, 1, 2, 3. And if the number of grains of sand on a given cell is larger than or equal to 4, then 4 of those grains of sand are split out into the neighboring cells. So basically we have a grid like with this many grains of sand, let's say. It's just a 3 by 3 grid. So most of them are less than 4, so nothing happens, but the middle one is 5. That means that in the next, that means we need to topple this one. The state of the grid has to update. So we have to take 4 from this guy, so it becomes 1. Then we have to split them out into the neighbors. So this one becomes 4, this one becomes 3, 2 and 1. So now we have 4 or more again, so we have to update that. We still have to update it. So we take away 4, it becomes 0, 1 goes here, 1 goes here, 1 goes here, and 1 goes off the edge. So we actually lose 1 grain of sand. And then this one again updates. And this one updates one more time. And now we're done. So you can see like just one update caused like a cascade of updates. And if you do this a lot, apparently you can get these like kind of interesting patterns like this. And like this, and here's one 30 million grains dropped on an infinite square grid. Things like that. So we'll take a look at that today, and as always we'll try to visualize it with RayLib. So let's get started. And sand piles. Sorry, while, I don't know why I keep writing if. So we can let RayLib do that, and this is not the best color. And here we go. So it's not gonna work because we haven't defined the run.sh, and we'll do this. We have to include RayLib and also link to it. And then there's some linking stuff here. This one we don't need, this one we don't need, but and also this one. The rest we do need. So let's try to run it now, and we don't have width and height. It's gonna be 800 by 800, and here we go. Okay, we are going. So we need some kind of grid, so we can call it a sand pile, and should have a width, number of cells in one direction, number of cells in the other direction. Yeah. And then we should have a height at each point. So that can be like, let's call it grains, something like this. And let's have a rectangle for the window. And let's also go into our previous project about the compute shaders. Copy this rectangle, which is in utils. because that's nice to have. So we have to define rectangle implementation and include that, because then we can say rectangle. Well, maybe we don't need that right now. Let's draw the sand pile, and we'll draw it inside the window. And let's say void draw sand pile. It takes a location, and actually it should also take a sand pile. And maybe we will take it by pointer. So let's initialize a sand pile here. And we should have, like, let's define the width. Let's make it always quadratic, and let's do like this. Here we add the pile, and we just draw a rectangle at that location, and we'll make it red. Okay, the full screen is used for this right now. That's fine. So let's start by saying cell width and cell height. And then we're gonna loop over, let's say, all the rows. So row less than pile height, and we're gonna use Copilot a lot for this code to set it up. And this stuff that's checking on the grains, I don't want right now. Let's get rid of that. Let's draw a red one, and let's check out this file. This one, I think. So we also need to define a cell here. And that is indeed how it is. So inside the cell, we draw a line of a black line of width 1. So let's see. Okay, now we have the world here. I will actually add a bit of a margin like this. And that didn't work. Why didn't that work? Well, okay, we need the stdlib anyway. Undefined reference to rect center. That surely is not it. There's a spelling mistake. Okay, there we go. So now you see there's a bit of a margin on the edges. Okay. Now we need some colors. So let's make a palette. And I think we will try something like, let's see if we can find the colors here. Magenta. These colors are not gonna look great probably. but there it is. So now we should decide the color. So we'll look at how many grains we have, and let's say that if grains is greater than or equal to 4, maybe we want just one more color, we can make it red. And then this can be like gray white maybe. And then the color is actually this. Yeah, let's do that. So now of course there's no grains anywhere. So maybe we want to do something like, if we click a cell, then we add a grain. So let's get the mouse and we check the collision between the mouse and the cell, and if we click something, we add a. So that didn't work because we used the color the wrong place. The color has to be here. And now everything is black if there's nothing. Maybe that's okay. So you can see we can add things like this. And I don't really like magenta, it's like too much. How about dark blue? Okay, probably that's fine. So now we need to update the sand pile. So how do we do that? Maybe we'll have like a delay. So let's say time since last update, and update interval can be every half second, and we'll say this, and if time since last update is greater than or equal to the update interval, then this one will be reset, and we will actually update pile. And we'll take the pile and do something to it. So we need to keep track of where there are too many grains. Now, if we have a very large grid, we don't want to loop through everything. I thought I wanted to try to use the data structure from data structure header from STB. So let's try to use that. So I think we need to do this, and then we need to include it. And it's actually quite simple. We can just do, we need to make a key value pair struct. We can just call it KVP. And the key is actually just an index. And then we can make a hash map like this. So let's see if it still compiles. It still compiles. And in principle, let's put this is kind of like a global state now. I'm not sure that is great, but whatever. So when we add a grain of sand, we should say, okay, if now this thing has more than 4, then we need to put it into the hash map. And the way you do that is like this. But here we have the key first and the value, but we don't really have a value. So we can do, actually it's, yeah. So we can do like this instead. And let's see if it runs. So yeah, that works. Now having maroon and red is probably not right. So maybe we make it violet. Yeah, that'll do. Now when we update the pile, I think first of all what we can do is here we can get the length, I think. Yeah, so we can get the length. So we can say hash map length of the hash map. And it's actually quite easy. We can just like say this square has a lot of sand. And then we can just say hash map and index it directly. Like that. So let's open it up here so the output is not buffered. So clearly like nothing now happens, but if I add one, you can see it keeps printing. So square 43 has a lot of sand. And we can keep adding squares. So this is a way we can loop over squares that have a lot of sand. And actually I want to do something like this. So if hash map length is 0, we don't do anything. Otherwise, the update index is, we can just take the first one. So as we pull things out of this hash map, it will rearrange the order of the items. So this is like semi-random, let's say. Okay, so we want to update that. And how do we update it? Well, first we have to take 4 away, and then we have to add them to the neighbors. And to do that, we do indeed need the row and the column. So we need the row and the column, and then we need to look up and down and left and right and see if that point is inside the grid. And if it's inside the grid, we add 1 to that. Okay. So the way I like to do it normally is like this. And here we can say X is instead Y. Like that. And if they are both 0, we can just skip this. And if they are, I don't know what I just did, and if they're both not 0, we also skip. And now let's say the new row is this and the new column is this, and if either of them is negative or greater than the width or the height respectively, then we also skip it. So if a new row is less than 0 or greater than the height, we continue, and same for columns. And then we add 1 there. Okay, but now we have to check if this thing is greater than or equal to 4, then we have to put it into the hash map. So there we go, it's into the hash map. So let's actually make a variable here which holds this stuff, and we'll say new index and new index, and here new index as well. Right. So I think that's great. That is great. I have reconsidered, well, maybe let's make the edge not black, but actually let's make it kind of a white. So I think this will actually do it. So when we get the index, this is actually a key value pair, so we have to say .key, that's fine. Right, so here we have the grid with a white border now. And now when I click one more time, it should be red, and then it should update almost immediately. And that's crazy. I don't really get what happened. So the problem is, now we have, so maybe we do it here actually. So we actually also have to delete the old one. So I think it's just delete, yeah. So from the hash map, let's delete the key, which is actually the update index. Let's delete that from the hash map. Now, let's see. So I click once and it should only update once. So I can do it again. And we can even do something like this to see a cascade. So there you can see that was kind of a cascade. And I don't know, so what do we do now? We just keep so we can keep it running for a long time. To make it a bit more interesting, maybe we do this, and maybe we do that, and maybe we just say, okay, in the grains, in kind of the middle, let's add 100 grains like that. Okay, now it looks horrendous with the borders, so I will get rid of that. Maybe that could be something here. So like draw borders. And then we also need std pool. And we'll say, okay, if pile draw borders, we do that. And then down in the main function, we're gonna say that one is actually false. Okay, because we need a comma. Right, so we have another mistake, which is that, okay, we shouldn't actually delete it unless it's less than 4. Then we delete it. But also no updates seem to be happening. And the reason for that is that we never actually added this to the hash map. So let's put into the hash map that index. So now we are going crazy. Okay, so it stopped here. It has this kind of symmetrical structure. Let's do 100,000. So I don't know why it's not doing anything right now. It's weird. That is weird. Maybe we need to get the debug out. So we build it one more time and then we say, okay, let's run that. Break on main, run. get everything initialized. Don't see a problem there. Now we can say, let's print the first one. It is that, whatever. And maybe we want to break inside the update function, which is called update pile. And let's run it. Sorry, let's continue. Okay, I think I see the problem. So I said that this taking the 0th was semi-random, but actually hash map index, it should be a random number like that, because otherwise we just sit there and we'll be updating the same one again and again and again. So it looks like nothing is happening. So let's do it like this instead. And we still need that one. Okay, so now it's a bit more interesting. Still, it feels slow. So let's say 5 times faster. See if we can even do that. So it should be limited by the FPS right now. Let's actually draw FPS. Yeah, so we can set this one to 0. Now it should just be FPS limited, and then we can set this one to 120. I think my computer should be able to handle this. I think it should be able. Another thing we can do is let's have a global variable that is updates per step, and usually it's just 1, but we can have here, let's say for int I less than updates per step, we do an update. And now if is key released, key 2, then we increase it by 1, and if it's if key 1 is released, then we decrease it, and then we should say, okay, if updates per step is less than 1, well, maybe if it's less than 0, we do this, so we can actually pause the simulation completely. And then I also want to draw some text, and we'll say updates per step is something like this. And that was not good enough. Let's put it there. Let's put it a little bit further, maybe. So now we have 1 update per step. We can increase that a bit, so the simulation like seems to run faster. Well, it does run faster, but actually we're just not seeing all of the steps. can go even faster. The problem is we have 100,000 in the middle, so it's gonna take a while for it to settle down. Okay, maybe I will just let it, I will let it run, and you can just skip ahead if you find it boring. You know what we should have added? We should have added a counter that tells us how many are in the central one. Should give us an idea of how long we have to wait. Alright, actually I'm gonna skip ahead, so I'll see you in a bit. Okay, I have decided that this is taking too long. What we're gonna do is we'll add 10,000 only, and then we'll also draw text. Format, grains at center is is this thing. And let's see how that one doesn't do anything. Did I forget to save? Still nothing. Grains at center. It's because it's like drawn under stuff. So here we go. Bit more, please. Bit more. Okay, so this is with one update per step, and actually I want to do if is key down, and the same thing here. So actually it's not that fast, which is of course because if you topple outwards a bunch of times, then eventually those will topple back in. So it's going, this counter is going up and down, but that's why it's so slow. So doing 100,000 is actually too much. But this is doable. And we just want to see the final pattern that we get. Please. And still not done. There we go. Okay, and that's it. That's the sandpile model. You can do many things with it. For example, choosing better colors like this green. Like this palette is just horrible. But yeah, let me know what you think, and I will see you in the next one.